was to get this. Believe it or not, the whole point was not to find the averages of these distributions. It was to get these graphs. Now, Warren, you said something as soon as, you guys had a yellow dice, correct? As soon as the yellow dice went up there, Lauren made a comment. What I'm going to do is, real quick, I'm going to control Z this a couple times. I'm going to take out the red and take out the blue. As soon as this yellow curve went up, Lauren, what did you say?
It looks bell-shaped.
It looks bell-shaped.
Sort of.
Sort of.
Yeah.
How about that orange one back there?
Yep.
Yeah.
How about that green one?
Yep.
Yeah. Sort of.
Yellow one, yeah?
Yep.
How about that blue one?
Perfect.
How about that red one?
No.
That one's harder to see.
No.
Now the reason, no. It's a little compressed. I got a sheet later where I blow it out and make it not so compressed. We'll come back to that one. So it looks like most of these things look bell-shaped-ish. Now if you compare them to the original distributions, were they bell-shaped? The red one was.
Right.
Was that orange one?
Well, no, but we
No.
didn't do it enough times.
What's it on times?
Well,
Infinite? Good. I got close to infinity. We'll get to that in a minute.
We did it 100, so it kind of started to average out a little bit better.
So, okay, average to what? Hang on.
You did 25.
Its own average?
What?
Average of
Hang on.
25 times.
Boom, 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 boom. There's orange. We're going to go through each one of these one at a time. That's the orange result. This is what's called a sampling distribution. You saw that term on your quiz you just did. Sampling distribution. It's the distribution of the averages you guys were collecting. So if you take all those averages you guys got and put them into a graph or a distribution, it looks like this. What's the average of this thing? What's the average of that distribution? Ish.
7-ish.
Looks like it's right around 7-ish, doesn't it? Looks like it's in this bar somewhere. What was the average of your population? Oh, sorry. What was the average of the orange population? But you're never going to know that, right? Right? We know it because of the dice, but in general you're not. But you see what we just did? We just sampled, and on average, we hit the average.
Wow.
Well, that's a pretty sweet, powerful. Now remember, you guys are just rolling dice. You have no idea why yet. We're gonna figure out why soon. Let's look at green. Green was your average right around 7 as well.
Yes.
And look where the high point of that bar is. Between 7 and 8, right? It's a little bit more towards this side. Lower weight on this side than this side, so the average would be more towards this side of 7, which I think is where your average was exactly at 7, I think, because it was dead center. But even though the bell curve is not perfectly bell-shaped, it's bell-shaped enough to show you the averages near the middle. Let's look at yellow. Yellow, where was your average? Actually, don't tell me. Don't tell me. Somewhere between 4 and 5?
Yeah, 4.5.
4. That's not bad, huh? And if I remember correctly, your distribution had a crazy tail off to the right side.
Yeah.
Where'd the tail go?
We didn't do the zeros.
Well, right, but we didn't get anything.
No,
Shouldn't we have gotten something out there?
Yeah.
No, but when we did it so many times, they were so insignificant that they went away.
Say that again.
They were insignificant.
Say the whole thing again.
After so many times of a roll, they were so insignificant that they...
So, now I want to go back to the distribution, which is freaking rad. Hang on, here's yellow. Here's yellow. Yellow right here. Okay, there's that crazy tail, right? Crazy tail. You can get an 11. I'm sure you guys, as you were rolling, did get an 11 at some point in your sample, right? But we never saw an average of 11 in your distribution. Why?
Because you're not going to get it that many times.
Because it's a what?
Outlier.
It's an outlier. By definition, what is an outlier?
Insignificant.
Something that doesn't, well, we say something that doesn't happen very often.
Yeah.
It's a more PC way of saying it. Something that doesn't happen very often. So if it doesn't happen very often, what's the chance of getting it, say, twice or 3 or 4 times in a row? You're not going to. You might get it once in a sample, but since there's so many 3s, you might get the 11 and 3 3s, and therefore have an average of, what would that be, 5, wouldn't it? 3 plus 3 plus 3 plus 11, the average is 5. Lauren, go.
I don't know, I barred for 3 super high.
Right! And then what happened?
I kind of moved.
What happened?
Right.
Oh, thank you for that, Lauren. What happened with your bar? What's your highest bar here?
4.5.
So, the bar in the sampling distribution moves away from the mode and becomes closer to the
Average.
boom! Isn't that what we're after most of the time? Oh, hell yeah. Let's look at blue. Here's blue. Your average, 8.5?
4.1.
It was actually 8.05 or something.
8.0, 8.1? Damn close. And actually, same logic. It's a bell curve. You guys like this bell curve, yes? It's a little heavier on this side than this side. So the average, I shouldn't have said 8.5. I should have said closer to 8 because it's actually pulled a little bit this way. So damn close to average again. And then red was the oddball, right? Red was the oddball. Control Z. Okay, can we tell where the average is there? I'm going to guess it's right around 9. Yeah. Now, I like what Lauren said about trials. Or infinity. Was that Carolyn? Somebody said about infinite number of trials. I love that idea. So here's the deal. First of all, one surprising result with all 5 groups. Or at least the first 4. Maybe you're not surprised with the red one as much. We'll come back to the red one. But what's one thing, Lauren, you noticed it almost immediately 15 minutes ago, and you guys are all noticing it now. What shape showed up in all the distributions? A bell shape. What the hell? Why would a bell shape show up? None of the original distributions except for the red one were bell
It's
shaped.
gonna even out over
Because
time.
you're at-
But why would it even out to a bell shape? Why not to a perfect triangle? Or why not to a uniform distribution? Hold that consideration. That's one thing that we noticed that was kind of cool, right? I like the evening out idea. So, bell shape. We'll take that for granted for a moment. We'll come back to it. What's the next thing that you noticed? What's the next thing that you noticed about all those bell shapes?
Same average.
Say that again, Nathan.
They're all the same average
As the original distributions. Look at these like masts of ships sticking up out of the water. The masts of those ships sticking up out of the water are right where the average for each of those distributions is. 4.5, 9, 8 point whatever it was, 2, 7. They are sticking up at the average of the distributions. The original distributions didn't even stick up at the average of the distributions. But yet the samples do. How freaking rad is that? Just so you know, here's the other class's results from earlier. That's their results.
Oh, very similar.
It's extraordinarily similar. I'm going to do both of them together here momentarily when I have you guys doing the next bit. Very, very similar. Look at their red one. Their red one looks almost identical to use it. They have a few more trials, I think, is the only difference. Isn't that cool? It's extraordinarily cool. The sample is telling you something. It's like the sample is telling you something.
Green was a little bit.
Say that again, Richie.
I was gonna say green was a little off.
Green was, well, a little bit off is called sampling error. Don't you worry about it. Now, what I wanted to do, and this is probably going to take us into, I want to address Lauren and Carolyn's point, but it's probably going to end up taking us into Thursday, and that's okay. Thursday won't go the entire time. I want to discuss this idea of grabbing more trials, because I like what Richie just said about the green being off. Here's green from them. Delete, delete, delete. There's their green,
Wow.
right? And here's your green. Delete, delete, delete. Okay? So you look at it, again, on average, it's sticking right about the same. I mean, the shape of the curve may be different, but on average, it's kind of sticking in the same place, yes? What I want to do, first of all, I'll undo that, not lose that data. Undo, 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 undo. Okay, good. Save this, don't lose it. Come back to it. What I want to do is, should have had this over already, I apologize. I want to analyze just the blue dice. Oh, hang on, it's open. There it is. This is just the blue dice. Now, this argument that we're about to analyze has to do with what Lauren